Well, hi, and welcome to our video series on the convergence of generative AI, spatial technology, and augmented reality. We're going to demystify this emerging and exciting world of convergence between these technologies. So let's start the journey. You're watching the Spatial-Next channel, and my name is Matt Sheehan. This is the first video in our series on the convergence of generative AI, spatial computing, and augmented reality. We live in amazing times at the moment. Technology is exploding. In 2024, when I've started doing these videos, we're going to see massive changes. I want to demystify this landscape. The focus of this series of videos is really on generative AI. I wanted to demystify that for those folks that haven't lived in that world before and want a sort of a high-level view about what is coming. But I also wanted to bring these other technologies into the same conversation. So this is broken up into really three parts. This first part is really talking about AI, machine learning, and specifically generative AI. Then we'll jump into the spatial world and how those connect, how AI connects into that world. And then the third part of this series will cover augmented reality. So we're quite ambitious in what we're doing. This first video, I'm going to just jump in and start explaining again at a quite high level what is augmented reality, what is machine learning, and how is generative AI a part of that universe. So that being said, let's jump in. So let's get started on this first video. So yes, we're talking about demystifying generative AI, and in this video we're going to be introducing the concepts that generative AI fits under. That is specifically artificial intelligence and machine learning. So let's just put up some high-level things that I've been reading over the last little while. So by 2025, that's next year, 40% of all new AI applications will be powered by generative AI. The global market for generative AI is expected to reach 100 billion. And 90% of online content could be created by generative AI. That is in 1 year pretty much. ChatGPT came out a year ago. We're now in 2024. These are very bold predictions about what's going to be happening. Real changes are upon us. But we're getting a little bit ahead of ourselves. So let's start at the beginning. I wanted to just give you a sense of some of this terminology that's out there. So particularly the two that we hear so much about. So artificial intelligence, or AI, and machine learning. You'll often see that described as ML. So what are these two mysterious things? Artificial intelligence actually dates back to the 50s. I believe I read somewhere that it was related to a research paper and getting something accepted, whether it was for money or just to get it academically accepted. But that's kind of where the term came from, and those folks in academia who still cringe about the use of that term, artificial intelligence, many of them don't like it. But it's a discipline, and what falls up from a definitional perspective, and you'll struggle to find a really concise definition, but here's a good one. It's the field of computer science that requires human-like intelligence, such as learning, decision-making, and problem-solving. You'll note I put there human-like intelligence. We'll dig into that a little bit more, the whole notion of intelligence and the whole notion particularly of learning. So that's artificial intelligence. What about machine learning? Well, machine learning is a subset of artificial intelligence, and its focus is training algorithms to learn to make predictions or decisions based on data. So that's the critical piece, based on data. So let's just talk about this at a high level, and this is a focus on machine learning, this picture. So there are three parts to the world of machine learning. There's the input, there's the model, and there's the output. And in this case, we've got a dog, an image, as an input. We've got a model which you can think algorithm, you can think function, you can think where all of that sort of logic is, all that brain power is, if you like, and it's more than that, is in the middle. and then the output is what you desire. So I'm actually going to switch to a video, and I'll get a chap named Steve Brunton to actually explain machine learning and this diagram actually in more detail. So back in a second.
Good. So what is a model? I said that machine learning is the process of building models from data. A model is essentially, I think of it as a function that takes in input data, and there are some output values that humans care about. And the inner guts of how that function evaluates that input-output model, there's a million different ways you could represent that model in a computer, in a program, as a function. But at the end of the day, it's an input-output program. So in this example, the input data might be a high-resolution image of either a dog or a cat. This is our dog, Mordecai. And the input data would get fed into the model. The model would be some function of x, where x is my input data. And this model would do a number of computations on that data. It might, run a little convolutional filter across it. It might look for ears and snouts. Who knows what it does? It might be some complicated function. And after doing all of this numerical evaluation, at the output is going to be some desired output. So for example, if I'm trying to build a classifier that tells dogs and cats apart, then my output might be a 2-vector with my probability of it being a dog and the probability of it being a cat. And if I do a really good job when I put in an image of Mort the dog, then this vector should return a 1, 0, because it's very confident that it's a dog. Okay, that's the kind of model we're talking about with machine learning. And again, the inner guts don't have to be a neural network. You could use a decision tree, a random forest, a support vector machine. There's lots of different ways of training this input-output function, of representing this input-output function. It turns out neural networks are one of the most flexible ways of representing functions, and so they're very widely used today. But neural networks is not all that there is to machine learning. So that's a really important thing to take away as well.
So I will include a link below this video to some of Steve's videos, which are excellent. But let's stay with some of Steve's terrific explanations. He spoke there about input, models, and output. Let's just focus our attention on models. Now, there are lots of models in the machine learning world. Steve, in this diagram, is talking about a couple of models. So let's just walk through that from left to right. So a system generates what's called training data. Now, we saw Steve talk about training data in the case of the video we just watched, which was a dog. It was an image. Training data could be any other different types of data. We'll start getting data which is video as training data, text which is training data, etc., etc. So training data is what is the input. Now, in this case, in this diagram, is that data for these two particular models, is it labeled or not labeled? So if we go to the top, no, it's not labeled, then it's unsupervised. So what one can get out of unsupervised data is different to what one can get out of labeled or supervised data. So our desired output, our desired outcome is going to be different. So as we walk through the diagram that Steve's got there, across the top, if it's unsupervised data, is it discrete or is it continuous? Again, we won't go into the details of what those mean, but at the end of the day, you get to a point where your output, your solution is maybe one of clustering, or it can be embedding. And again, I'm not going to go into the details here, but we'll use an example with the unsupervised world. We have lots of pictures of dogs and cats. They're not labeled. We can go, so it's unsupervised, it's the unsupervised route we're going to go through. So we can cluster those images using these models, or this model, to put those into two separate groups. This is a group of cats, this is a group of dogs. And that's kind of what that unsupervised world is. It's looking for patterns, it's clustering, it's that type of thing. So when we look at the bottom part of this, the supervised world, again, Steve's got that notion of, and I'm looking because I can't see the diagram properly, it's discrete and continuous. We've got a more fine-grained ability at the end of this. So we can do classification here. And again, if we use the dog and cat example, we can actually get that model to output, this is a dog, this is a cat. Those are the type of things that you can do with label data. And you'll hear a lot about this training data. And again, in this case, we're talking specifically about label and not labeled. When we start talking about generative AI and we talk about ChatGPT, this part of the conversation becomes very relevant. So that's an excellent diagram, I think, which talks about models. And I think we will talk actually when we talk in the generative AI section about some of the models that fit within the generative AI world. But more importantly, if you're going to understand machine learning, there are these many different types of models that are available to provide based on input and output. What's your end goal? And again, Steve talks a little bit about that in this video and a couple of other videos there. So the model that you choose is determined by what the input is and what that ultimately the result of it's going to be. Steve talks about neural networks there, and we're going to jump into neural networks in a little bit. That becomes super relevant when we talk about generative AI. Okay, so one more slide on machine learning, and then we'll move on. Now, this is probably the heaviest slide of anything I'm going to show, so I'll briefly walk through this again. This is aimed at folks that are not that familiar with this whole world of artificial intelligence, machine learning, and most importantly, generative AI. But I thought this was an important slide to kind of walk through quickly. How to train and build a machine learning model. There are really 5 steps to this. And again, I'm leaning on Steve's presentations for some of this. So the first thing one's got to decide is, what's your objective? What are you trying to get out of this exercise? So are you trying to, in the case we just spoke about, are you trying to cluster dogs and cats? Simple as that. So you've got to make a decision about what it is you're ultimately trying to do here. Secondly, curating data. So what training data have you got? Are you going to use for this? Is it labeled data? Is it unlabeled data, etc., etc.? So you've got to come up with that curation of data piece. Next is designing the architecture, and this is where most attention is focused. And again, when we talk about models, this is the model world. So what's the most appropriate model to use for that to achieve that objective? Is it a neural network? Is it something else? The next thing is to craft a loss function. So the loss function is again, we don't really need to go into too much detail about loss functions, but it's really the difference between the training data and the output data. Has a model done a really good job in generating an output which is similar to the training data? So that's the loss function. And then the last one is this optimization. So optimization is really talking about weighting. So what you're doing there is you're minimizing the loss function. You're actually weighting or tuning the model to actually achieve a better end goal. So those are the 5. And again, I've been super brief. If you want to dive into that stuff, then again, Steve and many other people will talk at length about this. And this is really in the world of computer science and data science as well. So if you're interested, that's really an important place for you to jump and to learn more about. So I've given a very high overview on those 5 steps. Really, really important. Okay, so let's summarize where we are now. This is a nice diagram which pulls all these pieces together. So we've spoken about artificial intelligence, and that's really the discipline of intelligence, learning, etc. We've also spoken about machine learning. And machine learning is machines learning from data, essentially. That's how one would summarize that. The third piece of this pie, which is what we're going to jump into now, is deep learning. And that's where we start thinking about neural networks. So those are the 3 pieces of the pie, and where generative AI sits is under this deep learning piece. So we'll dive now a little bit more depth into some of these more deeper concepts, if you like. Okay, good. So we're progressing nicely. We're getting deeper into the weeds here. We're now talking about deep learning, and we're talking about neural networks. Now remember, neural networks are just another type of model that takes input and spits out output. Neural networks have become very popular. And essentially, neural networks are trying to mirror the function and structure of the brain. You'll hear about neurons and connections between neurons, etc., etc. So in that diagram there, The left side is the input. The middle section, the sort of hidden section, as sometimes is often called, is the neural network with all these different connections and again neurons, and they can be very, very deep, very complicated. And then on the right of that diagram is the output. So neural networks is what we're going to be talking about when it comes to generative AI. There are lots and lots of neural networks, and just to highlight a few, I'll list a few here. If I can get my slides up. So there's supervised learning models, which we've already spoken about, where you've got labeled data. We've got unsupervised learning models. We've got computer vision. We've got predictive analytics. We've got speech, audio, and processing. There's a lot of different neural networks that are out there. Generative is one part of a much bigger whole. So again, neural networks, you'll hear a lot spoken about. They're very popular. But they are not the only models that are out there. They've become the most popular of the models. So that sort of sets the stage now for us to specifically dive into generative AI. So I'm not going to continue. I was going to do a little bit more on generative AI in this particular talk, but we're getting kind of long. So I'm going to do one more slide and just introduce generative AI to you. And then in the next video, we'll dive much deeper into generative AI, what it is, the different models that are there, etc., etc. So that's, we'll have one more slide. So just to close out this first video and to lead us into what we'll be discussing in the next video in the series, that critical question, what actually is generative AI? Indeed, why is it creating such a buzz in the world and so much excitement? In short, generative AI is a branch of AI focused on creating new content, such as images, video, text, and music. We've seen ChatGPT, which is a text-based primarily, and we'll talk in a lot more depth about ChatGPT, primarily a text-based generative AI solution, so text in, text out. But there's much more going on in the world of generative AI when it comes to creating images, music, and videos, etc. So the world is exploding of generative AI. In the next part of this video series, we will dive a lot deeper into generative AI, what it is, what are some of those models that are there, who are the main players, and again, we'll talk about some of the guys like ChatGPT and what they're doing and that sort of roadmap. So lots to come in this series. Thanks for watching it so far. Well, thanks again for joining me in this wonderful journey into generative AI, spatial technology, and augmented reality. We're going to cover a lot of ground in this video series. So I hope you like what you hear, and if you do, it would really be a big help to the channel if you did hit that like button. On another note, if you actually want to get automatic updates on when new videos come out, feel free to subscribe to the channel and you'll get that in your inbox. Again, we're entering a really amazing time in our world with these new technologies that are converging, and I hope to demystify that in this series. So again, thanks for watching, and I'll look forward to joining you in the next video.